I want to touch on a couple more operating system components and how they can be used by attackers to set up persistence mechanisms. So we should understand what they are, how they work, and how we can query them from an investigation standpoint. And so first we have services. And in Windows, a service is a type of process that runs in the background and does not have any kind of user interface. And services are typically used for system-level tasks like network management or disk management and providing certain system functionalities. We might also have things like update services as well. And if you remember from the core processes section, in Windows we have the Service Control Manager or the SCM. And the SCM is a special system process that can start and stop and interact with Windows service processes. And it provides sort of a centralized repository for service configuration and controlling and monitoring services. And so another way we can think of services are that they're essentially long-running executable applications or processes that run in their own Windows session. And these services can be configured to automatically start when the system boots up. And they can also run under different user accounts, and even system accounts that have much higher privileges than a typical user so they can perform their elevated service tasks. And because of this, services are often a prime target for attackers for both a persistence but also a privilege escalation purpose, where an attacker is trying to elevate a low-level access that they have on a system to more of an administrator or a system user role. So we can think similarly to getting root-level access on a Linux system. And so as SOC analysts, we should understand how to view and query services on a Windows endpoint to identify any abnormal or suspicious services or service configurations. So first, let's act as our attacker again and create a malicious service pointing to once again our notmalware.exe executable. And so to do this, let's hop back over to our Meterpreter session on Linux. And so this isn't the first time you see me do this, so I'll go through it rather quickly, but I'm going to open up MSF console in quiet mode. I'm going to use the multi-handler, set our payload to the Meterpreter reverse TCP shell, set my interface as the listening host, set the port to quad 4, and run exploit. Alright, we're listening and ready to go. Back in Windows, I'm going to open an administrator command prompt and simulate a user falling victim to an attack by running our notmalware executable. And we've opened up this session. So I'm going to drop into a shell here, and you can see we have an interactive administrator level shell on our Windows system. And from here, we can leverage the sc command to interact with services on the system. And the sc command is short for service control and is a command line utility in Windows that allows us to communicate with the Service Control Manager. And it allows us to do things like start or stop or restart or even create and modify services on the system. And so I'm going to run sc create to create a brand new service. And so for the name of the service, well, I'm just going to call it something very unsuspecting like backup service. And once we have our service name defined, well, we can now define the bin path or the executable path that the service will call and run when it starts. And so to do that, I'm going to run bin path with the capital P there, set the equal sign, and then within quotes, I'm going to specify the location of notmalware.exe. And lastly, I'm going to set the start configuration to auto. And this configures the service to start automatically when the system boots. And so I'm just going to run this here, and hopefully we're successful. And we are. So you can see the create service was successful, and we've created this backup service on the system. And so after creating the service, we can attempt to start it using sc once again. In this case, I'm going to run sc start, and then input the name of backup service. And so when I run this, you'll see that we're going to eventually get an error. And so this is going to hang for a second. And you can see we got a timeout error. And this is because service binaries, or the actual executables that we define in our service binary path, should technically be different from regular executables. And this is because real service binaries are often structured differently from regular application binaries to support the requirements of the Windows service and allow it to communicate with the SCM. And because we just used a basic Meterpreter payload, well, we're going to run into issues when we try to treat our payload as a service and start it up. But this won't actually matter for our simple demonstration. We can still go through with querying and enumerating services. And so once again, we've technically created another persistence method by abusing Windows services. And interestingly, if we were still listening on our Meterpreter payload, we would still catch the shell. And so once you create and start a service like we did as the attacker, well, it will run every time Windows starts because we set that start to auto. And so this means that backup service will run every time the victim system restarts and execute a reverse shell back to our machine. And so now that we've set up the malicious service, let's put our SOC analyst and investigator hat back on and switch back over to Windows. And so the first way that we can look at services in Windows is through the Services.msc utility. And I can just open up the taskbar and type in Services.msc. And then I can right-click and run it as administrator. And Services.msc is a Microsoft Management Console, or an MMC snap-in, that can be used to manage and configure services through a graphical interface. And so through the Service Management Console, we can see a list of all our installed services on the system, along with things like their descriptions and their statuses, so whether they're currently running or not. We can also see the startup type, right? So do these services have to start up manually, or do they start up automatically with system boot? And we can also see the user account that runs the service. And also from this utility, well, we can select and click on a service, and we can stop it or restart it. Or if it's not running, we can start it up. And sure enough, as we scroll down, well, we can locate our backup service right here. And if we right-click on any service, well, we can go down to Properties. And what we're really looking for here are things like the path to the executable, right? And so we can see here from this window that this service is going to execute not malware.exe. We can also see that the startup type here is set to automatic. And we could also optionally see any start parameters or command line arguments that run when the service starts up. And so what if we don't have access to the graphical user interface or a desktop environment? Well, of course, we have other command line options to view this information. And so I'm going to open up the command prompt as administrator. And for example, we could simply run the net command. Specifically, we can run net start. And this command will show us all of these services that are currently running on the system. And so we're going to get quite a big output here as it's listing all the active services. However, you can see from the output above here, we're not getting much information to go off of. Like, sure, we can see the names of the services, but quite honestly, that doesn't really tell us much and isn't really useful from an investigation standpoint. And so we can do more, and we can do better. And so to get more detailed information about the services running on our system, well, we can run the sc query command. And so when we just use it on its own without any parameters, it's going to list the status of all services and drivers currently running on the system. Right? And so we're going to see things like the state, whether it's running or stopped, and a bunch of other information about the status of the service. And again, this is only showing running services. And so if I modify our command a bit and include state equals all, well, this is going to list out every single service, whether it's running or not. And interestingly, when we do that, we can see backup service at the bottom of the list. And so to get details about a specific service, we can run sc query and just put in the name of the service. And so again, we're getting the same information from the original command, just filtered out to our specific service. And now, after we identify a potentially suspicious service, we might want to do more research into it and query its configurations or settings. And so to see things like the associated executable or the command line or the user that runs the service, well, we can use the scqc command. And so that's going to be scqc, not to be confused with query that we were running before. And this command is going to query the configuration specific to a service and include things like the path to the executable, which can be really useful for us when detecting services that are pointing to a suspicious binary. And so I'm going to run scqc and provide the name of backup service. And if I run this, well, we're starting to get some actually useful information here, right? So most notably, we have things like the start type, and we can see that this service is set to auto start. We can see the binary path name. That is, of course, set to the path of notmalware.exe. And we can see the service start name that's set to local system. So again, this is going to be the user account that runs the service. And of course, along with the sc command, we also have a PowerShell equivalent with the getService commandlet. And so if I open up a PowerShell session as administrator, I can simply run get-service. And if we run it on its own, well, this will enumerate and display the list of all services configured on our machine, and list out things like the name of the service, or the service description, and its current status. And so if we just wanted to list out the currently running services, well, we can run something like getService, and pipe this to the where object, and filter on the status variable that equals running. And so this is a little convoluted, but you can see it's going to filter out the status column here only to things that are running. And again, if we know a specific service name, well, we can run get-service and provide the name argument and set that to the name of the service. So in this case, backup service. And if we run this, well, we can see the name, the display name or the description, and the status of backup service. We can also use wildcards here, right? So if we wanted to pull back any service names that started with the letter B, well, I can type in B with the wildcard character or the asterisk here. And if I run this, we're going to list out and enumerate all these services that start with the letter B. And of course, we're only pulling back the name and display name and status here, which again isn't super useful when we want to get more detailed information. And so we can list out all of our available columns. If I just modify our command here, I can pipe it to select object. And once again, put in an asterisk to say we want to pull back every column available. And so we get more status-related information about the service. But unfortunately, there isn't a way for us to pull back the service image or binary path using getService, just like we did with the sc command. Since in this case, we need to query the Windows Management Instrumentation, or WMI, to get that value. So to be honest, I just use the sc query and scqc command. But instead, if we had to use PowerShell, we could use something like get-wmi object to again query the Windows Management Instrumentation directly. It's going to be a little bit of an involved command, but we can run get-wmi object, and we can set the class option to win32_service. We can provide a filter, and in this case, we can specify the name of the service we want to pull back. And so I can do that based on the name attribute and set that to equal backup service. And make sure to close out those quotes. And I can then pipe this to select object and pull back all of the columns. And if I run this, well, we're going to get some much needed information about the service configuration. Right? So along with the service name, we can see things like the path name. And again, this is pointing to notmalware.exe, which is something that probably wouldn't be named notmalware.exe in the field, but is something we would want to investigate, right? We can see things like the start mode, and it's set to auto. We can see the start name, or the user account that starts the service, is local system. Excellent. We could also use the get-cim instance commandlet as well. And quite honestly, it's going to be the exact same syntax as last command, but instead of WMI object, I can change this to CIM instance. And we get pretty much the exact same information. But the only difference really between the two commandlets is the protocols and security they use when accessing a remote computer. And so where possible, we can use CIM instance, but on older systems, we might need to use WMI object.